This video we're going to be looking at integrating using u-Substitution. Now when you're using u-Substitution you really need to be familiar with how to take a derivative, because there's no recipe for using u-Substitution. If you're confident and know your derivatives, then that's what you should be looking for. So in this problem, obviously it's not a standard integral, so I am going to use u-Substitution here. When I look at that, or more importantly, when I see that, the derivative of x cubed is 3x squared, and there it is. And then, of course, the derivative of 1 is just 0. So I'm already formulating a plan in my mind on what to do. So I'm just going to rewrite this now. And I'm going to move that 3x squared out of that numerator just by tacking on times 3x squared dx. Okay. So I'm going to let my u be x cubed plus 1. And then if I take the derivative of that, the derivative of the left-hand side is, the derivative of u is just 1 du. And the derivative of the right-hand side with respect to x is 3x squared plus the derivative of 1, which is 0, then all of that times dx. Okay. So there's my du. Isn't that nice? So this entire integral can be rewritten as 1 over u squared times du. And of course, 1 over u to any power, I can just rewrite that as a negative power like that, because now I'm going to use the power rule. And so I will integrate this now. And so according to the power rule, it's going to be u to the power of the original exponent plus 1, then times out the front the fraction, the original exponent plus 1, and then of course plus some constant c. And so this is going to be 1 over negative 1, which is just negative 1, then times u to the power of negative 2 plus 1 is a negative 1. And then the last thing we do is we want to write everything with respect to x. So I'm going to have a minus out the front, and then u, which was x cubed plus 1, to the negative first power plus c. This is a correct answer. Nothing wrong with that. I would expect to see that written in the back of the book, like in the parentheses to the negative first power is just the fraction of 1 over that. So I'm just saying, if there's if you have a multiple choice test and you got that on your paper, but the multiple choice selections look like that, okay, those are the same thing. All right, and you need to be equally comfortable recognizing either answer as true. Okay. All right, so let's go on to the next one. All right, what about this fella? Okay, so when I'm thinking of derivatives, I'm looking at that, and the derivative of x squared is 2x, and the derivative of 4x is 4, and derivative of 5 is 0. So 2x plus 4, and oh sorry, that needs to be a 2, my bad. That's a misprint, typo. So 2x plus 4, I can factor out a 2 from that, and then I'm going to be good. Okay, so let me now correct that. Don't know how that happened. Okay. Okay. So I'm going to rewrite now. Okay, so this is what I'm going to let u be. Okay. Now I need to take derivatives of both sides. So the derivative of this side with respect to u is just 1 du. And the derivative of this side with respect to x is going to be 2x plus 4 plus 0, and then dx. Okay, now I can factor out a 2. And isn't that nice? That's what I want. I just want this bit. I don't want the 2. How do I get rid of the 2? Well, I'm going to multiply both sides by a half, or I'm going to divide both sides by 2. All right, it's the same thing. Multiplying by a half is the same as dividing by 2. And so that's going to give me, and so that goes away. Okay, so now this is equal to a half times du. So what I now have is 1 over u times a half du. And of course this half is just part of that product. I can bring it out the front, which is what I'm going to do. Now I'm with a common integral here. I'm going to take that. So the 1/2 out the front is coming along for the ride. And the integral of 1 over u du is going to be ln of the absolute value of u. And then this is an indefinite interval, so we have to put plus c, plus constant. Then I'm going to want to go back to x, and so u is x squared plus 4x plus 5. Now, can we do any better than that? Let's see what the graph of x squared plus 4x plus 5 is. You can put it in your graphing calculator. Trust me, the graph of that looks like this. Now, what's so great about the graph? The graph is completely above the x-axis. So, all of your values of x squared plus 4x plus 5 will be positive numbers, all of your y values. So x squared plus 4x plus 5, no matter what x value you put in there, you're always going to get a positive number. So those absolute value symbols are unnecessary. And in fact, if you look this up in the back of your book, it would just have the parentheses in there if this was a book problem. Okay. All right. Onward and upward. Let's go on. Let's keep going. All right. Okay, let's fingers crossed there aren't any more typos. Okay. Okay, well, guys, the first thing I see is an x squared there. And the derivative of x squared is 2x, and I have an x out there. So, you know, the wheels are turning. So I want to move this x to there. I'm just going to rearrange this. It's a product. I can rearrange it any way I want to. Okay. Then times x dx. So that's how I'm going to rearrange it. Okay, so now I'm going to let u be all of that. We will deal with the -5. Okay, that's no big deal. So I'm going to let u be that. And now take the derivative of both sides. So the left side, the derivative with respect to u is just 1 du. And the derivative here with respect to x, well, I can factor out the -5, and then I can just take the derivative. The derivative of x squared is 2x. So I'm going to have -10x dx. Okay. So you can see there you've got x dx. You don't have -10 dx. I want to get rid of that -10. How do I get rid of it? I divide both sides by -10. I multiply both sides by the fraction, -1/10. It's the same thing. So I've done the same thing to both sides. So I'm going to have -1/10 du is equal to, let's cancel, x dx. Okay, so now x dx is going to be -1/10 du. And I'm ready to rewrite this in terms of u. So this becomes e to the u times -1/10 du. But the -1/10 is part of a product. I just bring it out the front. So now I can integrate because this is a common integral. So the negative one, let me go to black now. The negative 1/10 now is coming along for the ride. And the integral of e to the u is just e to the u. And then we have plus our constant. And then the last thing we need to do is to write it with respect to x. So I'll have times e to the minus 5x squared plus c. This is a correct answer. Nothing wrong with that. Nothing wrong with that. Those negative signs do not cancel. Don't try and do that. This is part of the exponent that's out the front. Okay. You might see it different in the back of the book if this was a book problem and you're looking at the answers, or if it's a multiple choice problem. Because e to the negative 5x squared is the same as 1 over e to the positive 5x squared. And then you can multiply those together. You just multiply the tops and the bottoms, numerators and denominators. Okay, so if it's a multiple choice problem, either one of those ways that I've boxed there would be a correct answer. Okay, so you just, again, need to be familiar if you're in a multiple choice situation on the different ways that a problem can be written. Okay, all right, moving along. Let's go here. All right. Let me give myself some space. Okay, so I look at x to the fourth and I'm thinking derivative is 4x cubed, and I've got an x cubed out the front. Okay, the wheels are turning again. I'm going to do a little bit of rearranging. And then I'm going to bring this. So I've just rearranged. I haven't changed anything. Okay. So I'm going to let u be what's inside here. Okay. So 3 plus x to the fourth. Then I'm going to take derivatives of both sides. So the derivative of u with respect to u is just 1 du. So I'm just going to write that du. And the derivative of this, 3 plus x to the fourth, with respect to x, well, the derivative of 3 is 0. The derivative of x to the fourth is 4x cubed, then times dx. Okay, now I just want x cubed dx. I want to get rid of the 4, and so how do we get rid of the 4? Okay, you see the pattern here? I divide both sides by 4, or I multiply both sides by a fourth. It's the same thing. So the 4's cancel here, which is what I wanted. All right, so now we're doing really good here. Now I'm ready to write this only in terms of u. So I have the square root of u times a fourth du. And now let's move the 1/4 out to the front, which we can do. And then it comes along for the rest of the ride. Now, if you remember, you want to rewrite the square root as an exponent. And the square root of something is the same as taking the argument, i.e. what's inside, and raising it to the 1/2 power. So now let me go to black. It's just easier to read. I have the 1/4 coming along for the ride. And instead of square root, I'm going to rewrite that as a 1/2 power. Then I'm going to use the power rule. So I'm going to have u to the power of the original exponent plus 1. And then out the front times the fraction 1 over the original exponent plus 1. So I'm going to have a fourth times 1/2 plus 1 is 3/2. I can leave that C because 1/4 times a constant is still going to be a constant, so you don't worry about that. Okay, now 1 over a fraction is the flip of the fraction. If you have 1 over a fraction, it's going to be the flip of the fraction. So This is going to be 1/4 times 1 over 3/2 is 2/3. Okay, now if I multiply 1/4 times 2/3, I have some cancellation there. I'll be left with a 2 in the denominator. And 1 over 2 times 3 is 1 over 6 times u to the 3/2 plus c. And then the very last thing we do is we write this in terms of x. And so u was that, and all of that will be to the 3/2 and plus c, and so that there is our answer. Okay. All right, and last problem. Last one. Finally. Okay. That. There we go. Okay, the derivative of e to the u is e to the u. Okay, so what I'm going to do with this one is I'm going to let me rewrite. And then I'm going to put this over here next to the dx. Okay. Now I'm going to let u be what's inside there. And then I'm going to take derivatives of both sides. So I'll have 1 times du over here. The derivative of 3 is 0. The derivative of e to the 6x with respect to x is e to the 6x, then times the derivative of the exponent. And the derivative of 6x is 6. Then all of that times dx. So don't forget that 6 part. That's usually a common mistake that students will make. So it's e to the u. The derivative of e to the u is e to the u, then times the derivative of u. All right, so I'm going to rewrite that again. I'm going to bring the 6 out the front. And I think we can see from here, we don't want that 6. So yet again, so out of all these problems, this step is always the same. We're just getting rid of this number out the front. So I'm going to divide this side by 6. I'm going to multiply this side by 1/6. It's exactly the same thing. And so I'm going to get 1/6 times du is e to the 6x dx. So this here is 1/6 times du. Now I'm ready to write this in red. So I'm going to have u to the 4th, so all in u, times 1/6 du. My 1/6 is part of a product. I can bring it out the front, and then it comes along for the rest of the ride. Okay, now it's a simple application of the power rule in that the integral of u to the 4th is going to be u to the power of the original exponent plus 1, and then out the front times 1 over the original exponent plus 1, and then plus a constant. And 6 times 5 is 30, so I'm going to have 1 over 30 times u to the 5th plus c, and then the very last thing we do is write it with respect to x. So I'll have 3 plus e to the 6x to the 5th plus c. That is a correct answer. I wouldn't be surprised if they put that into one fraction. If it's like in the back of the book, if it's a book problem, or if it's a multiple choice problem. Okay, this is also a correct answer. So either one of the things I've written in the box there is correct. Okay, I think this is all of them. Yes? Yeah, okay. Okay, that's it. So I'm going to stop this video. I hope it's helped you, and I'll see you for another video. Thank you.